we can use quadratic equations and factoring to find the dimensions of a rectangle if we know its area. So we're given a rectangle right here and we know its area. Our sides are labeled x plus 2 and x plus 7. So you guys recall from geometry that to find the area of a rectangle, it's base times height. So I know that this rectangle has an area, or a base and height of x plus 2 and x plus 7. So I'm going to multiply those together and set it equal to my area, which is 84. Now, we can't do what we've done in the past where we just draw the line and put each factor equal to 84. In order to solve by factoring, you must be equal to 0. So to do that, I've got to subtract that 84 over. So x plus 2 times x plus 7 minus 84 equals 0. The problem now is, though, we're no longer factored. It's no longer a multiplication problem. So I need to multiply these two pieces out, simplify, and then refactor the problem before I can solve this. So off to the side, let's do a little bit of side work. I'm going to multiply x plus 2 times x plus 7 together using the box method. If you know how to do FOIL or do that in your head, go ahead and do that. So when I'm multiplying with the box method, not factoring with the box method, I'm going to multiply on the outside, so x squared, 2x, 7x, and then a 14 right there. And then all those terms are going to get pulled out of the box and added together. So I've got an x squared. My x terms would add up to 9x. 2x plus 7x is 9x, plus 14, and then minus 84 is equal to 0. So once I simplify that, I'm going to have x squared plus 9x minus 70 equal to 0. And finally I'm at the spot now where now I can refactor this problem and then solve it. So it's a trinomial where the a value is 1, so I need two numbers that multiply to 70 and add up to 9. Two numbers that multiply to negative 70 add up to positive 9. So make your list of factors if you need to. I've got 1 and 70, 2 and 35 should work. I've also got 5 and 14 that works, and then I've got 7 and 10 that works. Knowing that one of my signs is positive, one sign's negative, I'm thinking that a negative 5 and a positive 14 would be a good combination to pick. So I'll factor this as x minus 5 and then x plus 14. Okay, and since I'm equal to 0, now finally I can go ahead and solve this one. I couldn't solve from the beginning because I wasn't equal to 0. So I'll draw my line between my two factors. I know my two solutions are what would make either parentheses equal to 0. So one solution is going to be positive 5. The other solution, potentially, is going to be negative 14. Now, if this was just a generic math problem, that would be it. Those would be my two answers. But don't forget what x represents in this problem. X represents the side of a rectangle. So having a negative side length doesn't make any sense. So I have to get rid of that negative 14. The only solution that makes sense in this case is x equals positive 5. If I want to check the answer, it's fairly easy to do. Let's take that 5 and plug it back in for our x and see how long the sides of the rectangle are. So this side must be 12 feet. 5 plus 7 is 12. This side must be 7 feet. And if I check and find the area, 12 times 7 does get me an area of 84 square feet. And let's do one more. The same idea, the only more difficult part this time is the factoring is a little more difficult to do. But the same basic idea. I've gone ahead and started it. I've done my base times height just like I did last time. I've set it equal to the area, and then I've multiplied out and rearranged so I'm equal to 0. So if you need to pause and kind of work through those steps yourself to make sure you get it, go ahead and do that. Otherwise, we're going to pick up from where I left off. So the 10x squared minus 4x minus 230 is what I want to factor. It looks like a box method because there's not a 1 in front. But before I do that, I notice there is a greatest common factor of 2, so that'll get me slightly smaller numbers to work with. So 5x squared minus 2x and then minus 115 is what I need to factor. Oops. So let's use the box method to do this. Like I said, same idea as last time. There's no difference in this problem other than the factoring's a little more obnoxious, but we can deal with it. So in the trinomial, I've got 5x squared as my first term and negative 115 as my last term. Those multiply together to get negative 575. So, yuck, I need numbers that multiply to negative 575 and add up to negative 2. Well, I went through and just very patiently on my calculator found my list of factors. I knew 1 and 575, obviously. I knew 5 was going to be a factor, and I got 5 and 115. But neither of those are going to add up to negative 2, so I kept going. It took me a while, but finally I found that 23 and 25 are also factors, and it turns out that that's the combination that I'm going to need. So a negative 25 and a positive 23. It took me a while to get there. I knew there was going to be some combination that worked, so it just patience. Just keep going through, keep dividing until you find something that works. So finishing this problem then, or finishing this factoring, I've got a 23x and a negative 25x. And finally, if I look for some common factors, these surprisingly had a 23 in common. I didn't know that. I thought it was going to be 1 until I checked it. But 115 is divisible by 23. These terms have a 5x in common. These only had an x, and these terms had a negative 5 in common. So my factors for this problem, going back to my work, was going to be x minus 5, and then 5x plus 23, with the greatest common factor in front. Once again, I want to go one step further and solve. So we know that 2 is not going to get us any answers. One solution is going to be 5 once I do that. And the other solution, if I set up what I'm actually solving, I want to put that factor equal to 0. So I'd subtract 23 and get 5x equals negative 23. And if you remember from last time, I know I can already tell that solution's not going to work out. I can't have a negative side length in a rectangle. So despite the fact it's a fraction, like fractions are fine as answers, but I can't have a negative answer. So that's not going to work in this case. 5 is the only solution. If I want to check it, notice this time it does say to find the side lengths. So I'm going to plug that 5 back in. It's a great way to check your problem too. So 2 times 5 gets me 10 for this side of the rectangle. 5 times 10 is 50. 5 times 5 is 25 minus 2 gets me 23. And if I check it, 23 times 10 does in fact work out to be 230.